Where's Clancy? Clancy sent me a video. I guess he deadlifted, was it deadlift or squatted? Squatted 500 pounds. That seems dangerous.
That's what I do for my weighted backflips.
Weighted backflips? I need to learn how to do those. That's only slightly less impressive. If I could do the standing backflip at my size. I feel like me and Gravity might have to have like a negotiation before that. It's like, look, we need to talk. I have to be able to pull this off in public. It's not going to work. It has to work. I could do a backflip. I used to be able to do a backflip off the high dive. I need enough time for the rotation to finish. All right. Homework for today was what? Oh, the sorts. How did that go? No. That's how it went. It went no. All right, so let's look at these. I'm gonna start sharing my screen. And then last time we were looking at variable binding, right? Okay. Okay, so we already have our merge step. We can all see it. Everybody online can see my screen shared. We're good-ish.
Si, senor.
All right. It's only funny the first time. That I think it's a commercial for like Duolingo or one of the language learning things. These two guys get in a car and they're like argue with each other at a gas station, and then they're in a car like on some road trip. And they turn the channel on, and it's like in Spanish or something. But these guys are like, not Spanish. They don't speak Spanish. And then they're like too lazy to change it. And then it shows them like hours later, they're at a gas station. They get out and they're arguing with each other in just fluent Spanish. It's a good commercial. All right, so what I'm going to do here is we're going to look at our merge code up here, because we're effectively doing a merge sort, right? And merge sort has two steps to it. It has, in fact, let's actually review merge sort. Do it on this slide right here. We'll just do a mini version of merge sort. Something like that. All right. So we look at this entire list here. We say, is this sorted? The answer is no, because it's not a one list. So we have this rule of being trivially sorted. So since it's not sorted, what do? We split our lists in half. And we call merge sort on the left half, and we call merge sort on the right half. So we make two separate calls to merge sort. All right. Then we say, is this sorted? No. How do we know? It's not a one list. Split, split. Is this sorted? Yes. Is this sorted? Yes. So now we bring these back together. We have two partially sorted lists. And we already have a function that if I give the list 2 and the list 1 to merge, if I give those guys to merge, I will be left with the sorted list 1, 2, right? So I'll call merge on those guys, and I'll end up getting a 1 and a 2. So now these guys could be assumed to be sorted in and of themselves. I call merge sort in the second half. Is that sorted? No, not a one list. Split it. Is 7 sorted? Yes. Is 4 sorted? Yes. Bring them back together, merge them. We have a 7 and a 4. And we get a 4 and a 7. So there's our merge step on those guys. Then we have bounced back up to our original call. We call merge on 1, 2 and merge on 4, 7. And we get those guys merged back together with 1, 2, 4, 7. They just happen to be in the right order. All right, here we'll throw a 9 in there. 1, 9, 4, 7, and we'll see that it still works. So there's our 1, 4, 7, 9. All right, so that's merge step. So we already wrote half of this with merge. All right, so now it's a matter of going through our list and making sure that we call merge on the proper things. Now, I'm actually going to go about this in the more complex way. There's sort of kind of a cheat trick to this one where you can call merge just on like the rest of it, not the other than the first thing. So it actually doesn't really merge sort is a divide and conquer type algorithm. So I'm sure somebody will bring it up once we get farther into it, but we're going to approach this in the more traditional way and see how this goes. Okay, so we're going to start writing. So define, I'm going to call this guy merge sort. And merge sort's going to be a lambda that's going to take in a list of integers as a parameter. Okay. And then we're going to, well, we'll have to ask some questions. If it's already sorted, so what does merge sort do? Merge sort sorts stuff, right? So if it's already sorted, we're done. So we'll do a cond in here, right? So we'll say cond. And our first thing is if our list of numbers is a single number. So if equals length LOI 1. If it's a 1 list, then what do? We'll return that list of numbers, list of integers. Already sorted, done. Okay, so that part's easy. All right, so if we have a 1 list, it's sorted. Otherwise, if it's a 2 list, what do I do? What do I do with what do I do with not a 1 list? Well, we saw here, I divide it. So this guy, originally we had, what, a 2 and a 1 here. Even though as a human, we can say, oh, well, this is not sorted. Really, the reason why we're saying it's not sorted is it's not a 1 list. So what do I need to do? I call merge sort on half of it, and I call merge sort on the other half of it. Now, realistically, and this is where the trick comes in here. We want to focus on the complexity of having to divide this guy in half. Technically, merge sort doesn't care if you divide it in half. So I can call merge sort on the list version of the car, and then the cdr, the whole cdr, and it will work and do all the merge stuff and things like that. It kind of bypasses the advantages of merge sort, so, but it also makes the splitting of it a lot easier. So if we want to go down that path, we can, and then I want to circle back here. So if it's not sorted, I know I need to get it sorted. So what am I going to do? I want to call merge sort in the first half, and I want to call merge sort in the second half. So let's just write those pieces here. So I'll call merge sort on the list version of the car of, and actually I need to put one other thing in here. We're going to say null list of integers will boil down to the empty list. So we'll need something to complete our final thing. We might need to change that a little bit once we get deeper into it, but we potentially are going to pass a cdr that has nothing in it, is the situation here. Although, is that true? I know if I'm calling merge sort here, I know I'm at least dealing with a 2 list, so the cdr would always have something. Yeah, I don't think we're going to need that. So I'm going to call merge sort on the list created from the car of LOI. That's the simplified first half, right? And I'm also going to call merge sort on the cooter of LOI. That's the simplified second half, not evenly divided necessarily, but simplified second half. So that's what merge sort's going to do in these. Now, what do I do with the results of merge sort? I merge them. We have this guy called merge that takes the result of one merge sort and the result of another merge sort. So I'll call merge on that guy and that guy. So that's what I'll do if the, in this secondary thing here. So this would, in terms of my cond, be our else. So if it's the one list, return the list. Otherwise, call merge on the merge sort of the left half and the merge sort of the right half. Let's do 1, 7, 2, 9, 5, something like that. So there's our answer. Now, it's correct. But it does defeat the purpose of merge sort. So I want to look at a more complex version of this. All right, but before I go into that, maybe a little demoralizing seeing the answer. What? that was it. But let's look at probably the path that you likely went down, right? The path of how do I divide a list in half, right? Which is interesting in and of itself. So let's look at that. And just for, if I want to kind of point out the interesting part here, this is where we're cheating. This first call to merge sort is supposed to be the first half of that list. But all we're doing is taking one element and turning it into a list. And then pretending like the second half is, well, not pretending. Then we're just giving the whole rest of the list to merge sort again. Eventually, those all whittle down to one lists, right? And it unravels. But there is substantial extra recursive calls in this version of this because we're not dividing our work evenly between the two halves. Okay, so let's look at the example here. So we're going to have a helper function that's going to attempt to divide a list in half. That's the only problem we're going to try to solve. I have a list. I don't care what's in the list, but I want to create two half lists. All right, so if we have something that looks like the list 1, 3, 7, 4, something like that, I want to produce the list 1, 3, and I want to produce the list 7, 4. I want to get those two lists. So I want to write a function that takes a list like this and produces the first half of it and the second half of it as lists. Maybe we can say it'd be really nice if I can get a list of list halves. A list of list halves might be nice because then I could say, oh, I'm going to call merge sort on the first half, which is the car, and I'll call merge sort on the second half, which is the catter. Okay, but rather than focus on the merge sort aspect of this right now, we want to say I have a list that looks like this. I want to divide it in half. How? How do I go about doing that? Okay, well, let's start off with maybe something along the lines of, we'll do a define, and let's call this guy a list splitter. I like that one, that's a good one. And this will be a lambda that's going to take in a list of integers as a parameter, and it's going to split those guys. Now, how many elements should be in the first half, and how many elements should be in the second half? Well, let's just answer the first question. How many elements should be in the first half of the list?
Roughly half, but you might have to do less or more depending on what you want to do if it's an odd number.
Half of what? Half the length?
Yeah.
So I want the length of my list, right? The length of my list divided by 2 is actually what I want. So what if, so I'm going to finish that guy here for a second. What if I had a list that looked like 1, 7, 2, 9, 5, and I said, so the length of that guy is what? Length of that guy is 5. 5 divided by 2. Five divided by 2 is, I think, going to give me 2.5 in scheme. It does give me 2.5 in scheme. I think I can say quotient 5, 2, and that'll give me the 2. All right, so I think I could also do floor divide 5, 2, and that'll give me the 2. So pick your poison, but we want the integer division, integer division part of it. So what if I said, to simplify this, I want to write a function that takes in a list and then a number of elements, so in this case it might be 2. And it should produce for me a list containing only the first number of those. Or maybe it's a range within those. So what if I said, give me from bucket 0 to bucket 2 inclusive? That gives me the 1 and the 7. And then I could say something like 1, 7, 2, 9, 5. Give me from bucket 3, 0, 1, 2, 3, 4, to bucket 4 inclusive. Actually, we're doing non-inclusive here. So we'll say from bucket 2 to bucket 4, like that. And that would give me the 2, 9, 5. So I call the same function 2 different times, and these give me subsets of the list. That would be handy in this case. Okay. So I want to write a function that takes in a list and gives me a range within the list. Chances are this function probably already exists in Scheme, but we're going to write it anyways, because I don't know what it is. I can make a guess at it, but it's going to be more interesting to write it. All right. So understand what we're trying to do here? All right, so how do I make sure I get to this first value? Because that's really the first thing I want to do, right? I have 2 values I need to count down. I need to get that first value to 0. And as soon as it's 0, then I can start building my answer. But until it's 0, I need to just start burning cars, right? Okay, so if we operate off the 0 thing first, I'm already there. But then I want to start building up the next 2 elements from my list, not including that guy, and counting it down. So I can do something like define, let's call this guy sublist, to be a lambda that's going to take in a list of integers, a start, and an end. And what we want to do is we want to get ourselves to the point where start is 0. We're just going to start ripping past cars until we get to a start of 0. Now, we can assume that it's start and end are legal in our example here. We don't need to do error checking and stuff like that. So what I can say here is I can say, we'll throw in our cond, and we'll say if greater than start 0, if that's a true statement, I want to call sublist on on my cdr of list of integers, everything but the first thing, along with the minus start one, whittle that guy down, and then keep end alone. Right? All right, so I'm going to keep whittling that guy down until start is 0. Now at this point, start's 0. If I pass this guy, I have a start that is equal to 0. Okay, so if I have a start that's equal to 0, what do I want to do? Well, I need to start whittling down end. So if greater than end 0, what do I want to do? I'm going to be building a list. So cons, the car of LOI onto whatever sublist returns for the cooter of LOI, along with, leave start alone. We can pass a hard-coded 0 if we want, doesn't matter. And minus end 1. Now, because we're doing a cons, we are going to have our catch-all for our empty list somewhere. So we'll have an else, boil down to the empty list. So sublist here. I barely started writing list splitter, so we'll just leave that alone. Let's see. So if end is greater than 0, I must be going through 1 extra time. If we look at the way we were doing this, I want to do 2, then 1 to get my last one not all the way down to 0. That only gives us our, oh, and I want to return list of integers. I don't need to do the empty list to finish my cons. Although that should have still worked. Yeah. I do want this to be the empty list. Say n minus 1 here. So I'm counting it down. Is greater than 0. Cons the first element, because we're keeping it, onto whatever sublist returns on the rest of the list with the same start, but 1 minus the end. So we want to get originally the 1 and the 7. So n came in as 2 to begin with, right? 0 to 2, but not including the 2. So I'm going to say, give me, so that's when it's 2, now it becomes 1. That's when it's 1, now it becomes 0. So we have our 1 and our 7. Next time through is 0 greater than 0? No. Is 0 greater than 0? No. So we'll go to our else, and we'll end with the empty list, which is here. Okay, I think that part's fine. So let's operate out the start. So if I go to 2, is start, if start's greater than 0, which it is, We'll just call it again on the rest of it. Start -1, so now it's 1, the end, leave end alone. Oh, wait. Since we just whittled it down, end has to change too. Let me keep walking through this. So I have less elements in the list. So I think end here needs to change as well. I think I need to say -end1. Even though I'm technically counting down start, I'm building a new offset from the end of my list. So that's why end needs to whittle down as well as start needs to whittle down, even though I'm only focused on getting start at the correct starting point. So that'll give me this list. So now I'm looking at 1 to 3, 0, 1, 2, 3. Then it'll give me this list. Now I'm looking at 0 to 2, 0, 1, 2. This was non-inclusive. So I'm still going to miss one here. So there's my 1, 7, there's my 2, 9. So I'm just missing one at the end. And it's because that second half needs to be the actual length of the list, not the thing divided by 2. There's my 1, 7 and my 2, 9, 5. So I just need to make sure when I call sublist, I pass it the full length for the second half. All right, so I think sublist, this will give me the 2 parts of a list now. So then I'm going to call define list splitter to be a lambda that's going to take in a list of integers. And we can assume that the list needs to be split, right? So what we're going to do is we're going to create a list out of, because ultimately I want to have a list that has the 2 halves in it, I think. At least that sounds like it would be a good tool to have for us. So list splitter will take in a list of integers, and then we're going to create a list out of whatever sublist returns for the my list, which is LOI, and 0 for the start, and the end will be the quotient of length LOI and 2. That's my first sublist. My second sublist will be LOI, and then the quotient length LOI 2, so the same starting point, all the way up to the length of LOI. So then what I should be able to do is I should be able to call list splitter on that. That should give me a list containing my halves. List first half, list second half. All right, so there's our list splitter. All right, so now if I'm gonna call this guy merge sort 2 or something like that. Yeah, we'll call it merge sort splitter. Even makes sense. Sounds cooler. I don't know if it makes sense though. All right. The length is 1. It's the empty list. So otherwise, we want to call merge on. So let's just back this out. Well, here, I'll just back it completely out. Otherwise, we want to merge the answer of 2 things. What are the 2 things? I want to call list splitter on my LOI. Which is going to give me a 2 list, right? So I'm going to call merge on merge sort of the car of that to list and merge sort on the catter of that to list, which will be the second half. I do. Thank you. Make sure we're calling the right version of merge sort. One, 2, 5, 7, 9. Wish you what?
I wish you had an error.
Well, I had a hiccup on the other one, but I did that on purpose just to make sure you guys were keep you on your toes. This is the way I would have intended for you to do the homework, something along these lines with the splitter and all that stuff. The other way is fine, but kind of a cop-out. Kind of cheats the algorithmic nature of merge sort, even though it makes the assignment, significantly easier. Out of curiosity, how many people did it this way with the cheat? I'd be interested in that. I want to see the rest of their logic. Okay. All right. So I'll go ahead and put this up on, I'll put it on Slack at the end. Okay, so any questions about this? Good with this guy? The length of a list? I would have assumed so. Yeah, but I mean, even if we didn't, you could define your own length. Null list, then return 0, else add 1 to my length footer of list. Or length. So, yeah, so I mean, and that kind of comes down to like even like up above when I said like our whatever I called it, sublist. There probably already is a function in Scheme that lets you say, give me the portion of a list from some bucket to some other bucket. But that's not nearly as fun as just writing it, right? And actually, there's some truth in that statement. I mean, I kind of said it in jest, but the goal is ultimately getting to the point where you don't really view it as a major setback. It's like, well, I can go and start looking for whether this is already built in, or I can just write it real quick. Because certain things are, call it simple enough that, like length there. got to think about it for a second, but you can knock that out relatively quickly where it's going to be a somewhat similar race to go and looking up that function in some obscure scheme documentation somewhere or something like that. So this kind of goes down to, I probably said something similar to this, like in 200, 250, where when you give a question, a lot of times students are just, they start searching through documentation or searching through online things, looking for something that is like the one function that just answers the homework. This is this magical function that just does it, as opposed to relying on yourself, and you're actually only hurting yourself then. So I might even err on the other side and just say, yeah, nothing's built in. Nothing's built into the language. Just write it all yourself, and you'll be fine. Huh? Yeah. See, that's where you start getting to the primitives of the language, where it would be problematic, because at some point, you don't have the tools you need to do anything. So you probably need the list. You need the list basics and numerics, like addition and subtraction and that kind of stuff. So yeah, something along those lines. Okay. And then let's see, sort on a predicate returns a list of elements sorted by the predicate. So it's in, so this goes down, we have to rewrite our merge to ask the question differently. So maybe have a merge pred. Yeah, so right now we're applying this less than thing where we would just replace that with our predicate and do the, the cons thing. Yeah, so that's it for that one. And then you would have merge sort splitter predicate. Yeah, let's just say that. Merge sort splitter pred. One, 2, 5, 7, 9. And if I did it greater than, oh, I need to call merge sort splitter pred. Merge pred, merge sort splitter pred, list splitter. That doesn't need to be the pred, merge sort splitter. What do I need? Oh, here. Merge sort pred. There we go. Nope, still not right. Should be 97521. Merge sort splitter pred. Let's merge pred. Let me just check my merge pred real quick. This is true. Oh, call merge pred. Oh, yeah. Where's Clancy on these? There we go. So just needed to make sure we were calling all the correct functions and passing the parameters that they were requiring. So there's our merge sort splitter pred. So not really a difficult exercise except for in making sure you're calling the stuff correctly. All right, so that covers the homework. All right. Did Clancy ever actually show up?
Yeah, I'm here now.
Well, figure maybe you were icing your knees.
No, I gotta ice my back more than anything. That's what hurt.
Did I send you the video? Maybe you sent it to me. I don't remember. Somebody sent me a video of this Russian guy like doing some sort of crazy squat, and it did not go well. You know
It
what I'm
might have
talking
been me. I've seen those videos before. I know exactly what you're talking about.
Yeah, well, we don't need to get any more graphic than that. It didn't go well. Knees. It was. Oh, I've seen it. Yeah, I've seen it. Yeah. But I think that might be kind of like an international sport, or is it only in Russia?
Everyone I've seen is just crazy Russian.
Yeah. I'd pay to go watch that. It's just two guys that stand there and they take turns slapping each other across the face as hard as they can until somebody blacks out. And it's like there's a whole strategy to it and everything. I mean, it's like it sounds like it's a joke, but it's not. Like there's actual referees. It's like from the movie Dodgeball. If it's almost a sport, it's on ESPN 8 The Ocho. Great movie. All right. So we started talking about variable binding last time, and we explored this through the idea of occurs free and occurs free, occurs bound, and really drove home this idea, the difference between where does a variable occur, where does a binding occur, and then where does a variable occur in terms of when's the variable being used. So we operated off this. So a variable occurs in this identifier portion here. A binding occurs in this portion here. And a binding is bound, and a variable is bound to a value in this guy here, where the second parameter typically would be the value we're binding to this identifier in this lambda here. It would be typically how it would be ultimately written. So for us, the idea is what does it mean for a variable to occur? First of all, it occurs in this production of this grammar. Okay, so I'm going to come back to that one. And we wrote occurs free, occurs bound already. Yeah, we wrote occurs free, and we did this in terms of occurs and bound. All right, so now having said that, let's assume that when because we're kind of trending towards writing our first interpreter. That's the goal here. Now, when we talk about, so effectively what we're saying is we are writing our own interpreted programming language, right? And for a programming language to be interpreted, it means that it gets executed at runtime, right? Now, but it is still a programming language, right? All programming languages provide us what facilities? 100% of programming languages have to give us memory, some way of defining variables, asking questions, repetition. Well, we're not to that point yet, but defining variables, memory, what does that imply that we must have? we have to have some sort of variable environment, something that where values can be set, values can be bound, and then values can be resolved, right? So what we talked about last time is this idea of, yeah, this is where bindings occur between these two, and this is where they need to be resolved, right? Those are functions, right? When I resolve a variable, I have to go and look up that variable somewhere and come back with its value. The question is what is that somewhere? What am I talking about when we say somewhere? Similarly, when there's a binding, when we have this value getting bound to this identifier, that name value pair, I have to remember that somewhere. That has to be somewhere. So now the question is how do we represent a variable environment? That's up to us. So we're language designers. What's a variable environment? Well, what's a variable? Variable name value pair? Fair enough, short and sweet, right? So a variable environment would be a collection of name value pairs. So what might be the simplest way to represent that? Well, so probably a list of something. Okay, and what would we have in the list? So probably a variable name and then its associated value in like little two lists. So a list of two lists. Maybe if we're trying to just keep things as simple as possible, that throws the idea of like scope and stuff maybe out the window. But you know, hey, you want to add something to your collection? No problem. We have a list of two lists, and those two lists are where your variables live, right? Okay. So maybe if I do something like A is equal to 5 and B is equal to 7, I want to represent something like that. Maybe this ends up being a list where A is 5 and B is 7, like that. A list of two lists, a list of name value pairs. Okay. So if we're going to write this, so one of the things that the book starts trending us towards is having this idea of constructors for working with, for us, we're going to have a constructor for working with variable environments. Let me actually look this up, because your next assignment is going to be creating those procedures. Yeah, so let's actually write it for our variable environment the first time around then. All right. Yeah, this will let us accomplish it. All right, so we're going to be working with an environment interface. We could write just standard lambdas that kind of allow us to apply this, but effectively what we're going to do is we're going to build on top of this. So let me rewrite. I just want to kind of prepare you for the next assignment. We're going to be skipping to this step pretty quickly anyways, but we're going to rewrite this guy. Where's my, okay. So we started out with an empty environment. And then what we did is we extended that environment with an A and a B. I'm sorry, an A and a 5. So that gave us an extended environment, which now produces a new environment. So extend env is a constructor for an environment that takes a single name value pair as well as an environment. Think of it kind of like a cons is constructs a list. So instead of adding a single thing to a list, we're adding a name value pair to a list. But instead of a list, it's an environment. And then I'll extend that environment again with B7 in that extended environment. So here is my default constructor for making an empty environment. That's a list containing the symbol empty env. I can extend that using my constructor for extend env by passing it a single variable name and then a value associated with that variable name, as well as an environment that I'm extending. And this whole thing then produces for me a new environment, which I can then choose to extend with another variable name and a value. And this guy will then produce me a new environment. All right, so ultimately environments they're growing things and they happen in terms of these constructors. Make some sense? So let's kind of write this, this idea out here. So we're going to define these, so I want to think about them like constructors. So I'm going to define a constructor for an empty env. And this is going to be a lambda that takes no parameters and boils down to the list empty env. That's what that constructor does. Make sense? Sort of kind of a waste of time, but this allows me to define things in terms of that constructor and potentially then change the way that my environments are constructed internally. So that if I want to upgrade them to handle scopes and things like that, I don't have to go and reinvent the wheel. I could still use the same constructors I had before, they just do different things than they used to. Okay? So that's going to be my simple constructor right now for an empty environment. Then I'm going to define extend env. Okay, extend env is going to be a lambda that takes 3 parameters. What are the 3 parameters this guy takes? I extend my environment by exactly 1 name value pair. So what 3 parameters do I need for extend env? So a variable name, a variable value, and then the environment for that, right? And then what will this guy ultimately construct? It'll construct a list for me. Extend env with var name, var value, and whatever the old environment was. Feels like, oh, we have no logic in here whatsoever. It's okay, these are constructors. We haven't done logic yet. We are constructing a data type that holds our information. Then we're gonna start applying these things when we want to resolve a variable. You'll see that here in a minute. So if I want to create this environment that has my a equals 5, b equals 7, assuming that's what I had, I would say, I would call my extend env, passing it a and 5, along with extend env, b and 7, along with the empty env. Oh, sorry. I need to quote those. So here is my list containing an extended environment with a and 5, which extends this environment, which is an extended environment containing a b and 7, which extends my empty env. Oh, sorry. That's a function call. Which is my empty environment. Because empty env is a variable name which holds a lambda. If I actually want to get the output of that, I have to call it as a function. And that gives me my empty env portion of it. All right. So this is a way that we might hold an environment. Make sense? So I'm going to go ahead and I'm going to define sample ENV to be this guy. That way I have a variable that I can mess around with that holds this example environment. Okay? All right, so now we want to be able to do things with this environment. So we want to be able to apply this environment. So apply my environment takes in an environment and the variable I'm looking for, and ultimately gives me the value of that variable. Make sense? So this is our logic associated with a data type. So I've defined this data type called an environment that's determined in terms of empty environments and apply environments. Now, we might want to create some predicates, right? For determining which kind of animals we're dealing with here. That might help us inside of our function we're going to build for apply env. What's a predicate again? So like a Boolean, it's a function that boils down to a true or false. So we'll go ahead and we're going to say empty. I'm going to define empty env, maybe with a little question mark at the end of it. And this guy will take in, he'll be a lambda that takes in something that is an environment. So something, we're not going to error check on whether or not the type of animal we're looking at is an environment or not, but he takes in something that is an environment, and he should return true if that environment is the empty environment and false otherwise. How can we identify the empty environment? How would I check to see if something is an empty environment? What's the base data type for an environment? It's a list, right? I have two different kinds of environments. Do all of those contain something in the list? What does my empty environment contain? Something, one something, right? Just a word. And then what's my extend env have in it? Well, a word and then some other somethings, right? So I can look at the car of this list and determine what it is. I can look at the car of this list and determine what it is. So for empty env, I'm going to return EQ car env with empty env. That's what that predicate does, right? Returns true if I'm looking at an empty env. That is, if the environment's car has the word empty env in it. How do we know that's the case? Because that's how we defined an empty environment, as something that is a list containing just the symbol empty in env. Keep in mind, this is our invention. We could have made that say elephant. We could just said our empty environment just has a list that says elephant in it. Just because. I lost my screen. That one's still on, isn't it? We do a chiropractic adjustment. All right, so that's empty env. So now define extend env, which we might not necessarily know, need to know, because extend env would be not empty env, right? But we won't write it in terms of empty env. Instead, we'll say it's a lambda that takes in an environment and returns equal car env extend env. Like that. Okay. And then we went ahead and using our constructors here, we went and built we built a sample environment. And if I call empty env on my sample env, I'll get a false. And if I do an extend env on my sample env, I'll get a true. Because my sample env is not an empty environment. My extend env is an empty environment, or I'm sorry, my sample ENV is an extended environment, so I got a true for that one. So far, so good. All right, so now that just tested those couple of things, we want to define apply ENV. Apply ENV is going to be a lambda that's going to take in a var name and an environment. And it's going to, so I'll just put a little thing here, returns the value associated with var name or false if not found. That's what this function is going to do. So take a couple minutes, try to write apply env, which will be a function that takes in a variable name that we're looking for the value of, as well as the environment in which we're looking for it. And it should return either the value or a false if it's not found. So you're going to be walking through our environment data structure. cool. Apparently I bought Carnival stock again. I've been playing this yo-yo thing since January. I bought Carnival at 8. I sold it at 12. I bought it at 10. I sold it at 14. And so I think I bought it at 12 and sold it at 18. No, 14, sold it at 18. And then I put in another buy for if it ever hit 16 again. And it did. So I just bought again. And I got to put in my sell at 20. Maybe I'll just put it in 18, just get a quick win. It's like a video game. All right, so let's take a look at this. I just got a notification from my account that you bought a bunch of Carnival. I'm like, oh, I didn't think it was going to go back down to that. All right, so we're writing apply ENV. And what we're doing is we're searching through this environment for that guy. Now, I'll do a cond, and I'm saying, well, if it's an empty ENV, which I have a predicate for, then I can just boil down to false, right? Didn't find it. Otherwise, if it's not an empty ENV, it must be an extend ENV. Now, what might be handy is for me to have getters for extend ENV to be able to extract pieces from it. So maybe something like a define, not that I have to do this, but it would be a more convenient way of writing it, make it look cleaner. So I can say, maybe get var name, and this guy would be a lambda that takes in an ENV, and it will boil down to the car of an extend ENV is the extend ENV word. So it would be the car of the cdr. So this would be the catter of my environment is that variable name. Define get var value will be a lambda ENV, and this will return the car of the cdr and cdr of the ENV. So now I have the ability to ask the question. EQ var name with get var name ENV. If those are equivalent, then boil down to get var value ENV. That's if I found a match. So if the variable name I'm looking for is the same as the variable name I'm currently looking at, then return the value associated with that variable name. Else, call apply ENV on the next environment. Def get next ENV is a lambda that takes in an ENV, and it returns the car of the cdr of my ENV. Because an extended environment is the word extend ENV, variable name, variable value, and then another environment that I'm extending. So apply ENV on the same var name I'm looking for and get next ENV from ENV. And now I should be able to say something like apply ENV A, apply ENV B, apply ENV C, and I should get the values and then a false. This is define Clancy. Oh, sorry. Give it my sample environment to look in. So there's my 5 and my 7 and my false. So now we have an environment data structure along with the ability to look up variables in that data structure. Okay. Homework for Thursday is this guy right here. I don't remember. So it's homework number 6. Homework number 6. All 3 of these exercises, these deal with binary trees. You're going to be writing kind of constructors similarly to what we just did in our environment, and then writing some procedures that operate on those. All right, so 3 different functions you're right. First one is going to be like our environment in terms of the data structure, and then the rest of it is going to be operating on that. So this guy will be kind of like apply, E&D. This guy will be another one that's a little bit more difficult. This gives you an example of it down here. So the difficult one will be 133. Questions, comments, concerns, bribes? All right, I will see everybody on Thursday.